This lesson is going to be really similar to what we did in 7-2. The biggest difference is you're not going to know what the population standard deviation is anymore, so we can't use Z. We have to use our T distributions. Finding critical values on your T chart. This graphic here is from your book, but pretty much what you're going to do, if you look on your T chart, at the top, when we were doing confidence intervals, we used where it said level of confidence, that row across. The two right below that are alpha values. So you can see it says one tail, and then there's different alpha values, and then two tails alpha values. So if it's a left tail or a right tail, you're going to use the row that says one tail. And if there's a two-tail test, you're going to use the two-tail test, and then go over to whatever your level of significance is. You're going to go down to the degrees of freedom for the problem. Remember, degrees of freedom is one less than the n value, and that's going to be the critical value. Now, in here, the critical values are all positive, so you're going to have to remember at the end, if it's a left tail, you're going to make it negative. If it's a right tail, you're going to make it positive. And if it's two-tail, you're going to use 1 plus, 1 minus. Just put a plus or minus symbol in front of the number you find. So that's the first thing that we're going to do, is just practice finding these real quick. Okay, so it says find the critical value T sub 0 for a left-tailed test with a level of significance of 0.05 and n equal to 21. So if n is equal to 21, what is degrees of freedom equal to? Other way, 20. Okay, so left tail test means one tail test. All right, so we're going to find one tail at the top. We're going to go over to where it says 0.05 and then go down to 20 degrees of freedom. So find it with me here. Let's see, what was it? 0.05, one tail. Second column, 1.725. And because it's a left tail test, we put a negative in front of that because it's on the left side of that curve. Okay. Find a critical value for a right tail test with a level of significance of 0.01 and an n of 17. So if n is 17, what's our degrees of freedom? 16. Okay, again, right tail test is still a one tail test. So on your chart, find one tail, go over to 0.01, which is the fourth column over, and then we're going to go down to 16 degrees of freedom. You should see 2.583. And then you just use the positive number for a right tail test. Okay. Last but not least, two tail test. So n is 26, which means my degrees of freedom are 25. Okay, so this time you're going to use the row that says two tails. Go over to your level of significance, 0.1, which is the second column, and then go down to 25. 1.708. And if it's a two-tail test, we put a plus or minus in front of it. Okay? So those are what start our rejection regions when we were drawing those with our hypothesis testing. So that's going to create those shaded areas that we can choose to reject or not reject with. Questions on that? Do you need to practice that again? Or are we good? Good. We're good. Okay, great. All right. So you need your calculator for this. So we did hypothesis testing two different ways in section 7-2. We did it by finding a p-value and comparing it to alpha, and then we did it with rejection regions. Finding a p-value with a t distribution is not as easy as with the z distribution because we have all those areas listed for us with the z distribution. So you will only use your calculator to do this. Actually, I'll use the calculator on the screen. When you're using a p-value to do hypothesis testing when you have a t-test, okay? So what we're going to do, let's kind of run through this problem real quick, and I'm going to fill in on the side there what all my variables are, and then we'll go to the calculator and type it in. So it says Department of Motor Vehicles office claims that the mean wait time is less than 14 minutes. A random sample of 10 people has a mean wait time of 13 minutes with a standard deviation of 3.5 minutes. At a level of significance of 0.1, test the office's claim. Assume the population is normally distributed. So if we were doing hypothesis testing, it's normally distributed, check. Then we look at our standard deviation. The standard deviation here is a sample standard deviation. So immediately I know I'm not using Z's, I'm using T's. All right, as soon as I know I'm using T's, I can label my other variables. Starting with my population mean. Okay, so that's part of the claim, that number. What number is part of the claim? What mean? 10 is my sample size. So maybe let's write our claims out here. The null and the alternative. So the claim that's being made is the mean wait time is less than 14 minutes. Is that the null or the alternative? That's the alternative. The mean is less than 14. And therefore, and that's the claim. Let me label it. Try that again. Okay, and then the null hypothesis would be what? That the mean is greater than or equal to. Okay, so that 14 that shows up in your hypotheses and your claim, that's going to be the null number that we're going to use. Then there's a sample mean and a sample standard deviation. The sample mean is what? 13. And the sample standard deviation is 3.5. Okay, and then this is a less than alternative hypothesis, which is making it really a left tail. So you're going to choose that option when we get to the calculator on that last line there. Okay, so in the calculator, we did this before with the t-testing. We're going to go into stat. We're going to go over to tests. So if you're hypothesis testing, you're going into tests. Z-test, if you know the population standard deviation. T-test number 2, because we do not. And then you can either do it with the raw data. So if you had a set of sample data, you could use the data. Or if you have statistics like this, you can use stats. Mine's already selected for stats. And then let's put those numbers in there. So the population mean 14, sample mean 13, sample standard deviation 3.5, sample size 10, and then you're going to choose the less than option to tell the calculator that's a left tail test. Okay? And then we're going to hit calculate. And we get this information. What we really care about from this is the p-value. So here the p-value, which is essentially like the area under the curve, you can think of it as, that it's calculating for us. Just a little hard to get from our big distribution charts. So p is about 0.19. And remember, alpha was equal to 0.10. We compare the two. In this case, p is greater than alpha. So do you remember if that means reject or not reject? It is not reject. We do not reject. So what that tells us, if we had to summarize then, if we were doing hypothesis testing, is we would say there is not enough evidence to, because the claim is the alternative, support the claim that's being made by the Department of Motor Vehicles.
So is this one outside the curve or inside like the shaded region?
So if I were to draw this, let's see, 0.1 would be down here somewhere, 0.19 would be over there somewhere. So it's outside of the region. Yep. Okay. Good. Great. Okay. So you guys try these two. Okay. So test the claim about the population mean with a level of significance using technology. Assume for both of these that the population is normally distributed. Okay. So use your calculator, find those p-values, compare them to alpha. If p is greater than alpha, we don't reject. If p is less than alpha, we do reject. So on the top one, I got a p-value. I rounded a little bit, about 0.02, which is less than my alpha, so I choose to reject. And then if I had to make a summary statement on that one, the claim there is an alternative hypothesis, so I would say there is enough evidence, because I rejected, to support the claim, whatever that is. And then the bottom one, I got a p-value of about 0.048, which is bigger than alpha, so I do not reject. So if I had to summarize, I would say, because I don't reject, there is not enough evidence. And then there, the claim is that it is a null hypothesis equal to, so we say to reject the claim. When you do that bottom one in the calculator, those last options, you choose the one that's not equal to. That's the one that means a two-tailed test, which is what this would be. whatever that alternative hypothesis is that you're choosing. Okay, any questions on those? Finding a p-value to test a claim. Okay, so then the last slide today is this one. This is just super quick. So tomorrow we're going to do hypothesis testing with rejection regions with our t-distributions. So this is just another quick test. It's basically the same thing we did with the z-values. So on the first one there, you can see I have a right tail test. My critical value is 1.402. If I had a t-value of 1.4, would I reject or not reject? Well, where's 1.4? Is it in the shaded region is the question.
No.
It's not. It's a little bit less than 1.402, right? So it's going to be to the left of it. So it'll be like right in there. 1.4. So we would not reject. 1.42, reject or not reject? That would be a reject. What about negative? We would not reject. Okay. What about on the right side? We got a two-tail test, critical values at plus and minus 1.725. Would I reject negative 1.755? Yes, we would reject that one. It's going to be over there. Okay. What about negative 1.585? Not. And then what about 1.745? We would reject. Okay. So tomorrow we'll just do probably like 3 hypothesis tests with the t-value, and that'll wrap up the section for us. So you guys have almost a half an hour now. You can work on your 7.2 Math Excel that's due tonight, or you can start 7.3. Sound good?
Sweet.
Great. All right. That's all I got for you. Oh, cell phone login. Let me do that. Six. You can use the boards if you want for your homework. If you want to keep them out, feel free.